Hello everyone, myself Mrs. Vidhi Mathur, PGT Physics, KV number 4, Jaipur. Today, in this lesson of current electricity, we will continue with the following topics: Ohm's law, VI characteristics, resistance and resistivity, conductance and conductivity, temperature dependence of resistance, ohmic and non-ohmic conductor. Before starting these topics, let's discuss steady current in the circuit. As the maintenance of steady current can be explained by this diagram of water flow. As the water flow from higher level to lower level, it is connected through wall. If the wall gets open, water can steadily move from A to B, that is from higher level to lower level. But if the water has to flow from B to A steadily, then the work is to be done by water pump. So this water pump will flow the water from lower level to higher level, and it will maintain the steady flow of water. In the similar manner, the cell or the battery gives the steady will do work for the steady flow of current in the conductor. So steady current in the circuit will be with the help of battery or cell. Now let's talk about Ohm's law. What is Ohm's law? It derives basically a relation between electric current and potential difference on the basis of experimental observations, and it was performed by German physicist Georg Siemens Ohm. This law states that electric current flowing through a conductor is directly proportional to the potential difference across two ends of the conductor when the physical condition such as temperature, mechanical strain, etc. remain constant. So this point is very important, that the current will be directly proportional to potential only when the physical condition remains constant. If I is the current flowing in the conductor, V is the potential difference across its two ends, then as per the statement of Ohm's law, V is proportional to I, or V is equal to IR. This R is a proportionality constant and it is called resistance. Other formula we can have I equal to V by R or R is equal to V by I. These formulae can be remembered by this VIR triangle. Now, to measure the resistance of the wire, we need certain connections, and we get this is the circuit diagram for it. This is the resistor. The resistor is connected to a battery source through a rheostat. This rheostat will vary. With the help of rheostat, the potential across the ends of the resistor will vary. The voltmeter is connected in parallel to the resistance so that it will measure the potential difference across the ends of the resistor. Ammeter is connected in series to measure current flowing in the resistor. When the rheostat slides, the potential across the ends of the resistor varies, and as a result the current also varies. So if we plot a graph between a voltage potential difference versus current, then we get a straight line. Now, what is resistance? Resistance is the opposition offered by the conductor to the flow of electric current through it. Previously, we have seen one example of water flow. If during the flow of water some hindrance, some opposition comes, some obstacle comes, then it opposes the flow of water. In the similar manner, the resistance is opposition offered by the conductor to the flow of electric current. It means that more the resistance, less is the current for a given potential difference. It is the ratio of potential difference applied across the conductor to the current flowing through it. SI unit is ohm, and this 1 ohm resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through it on applying a potential difference of 1 volt. Any material that has some resistance is called resistor. Now let's talk about resistance in terms of physical features of conductor. As we have derived earlier that I is equal to NEA VD, where I is the current and the number density of electrons, E the electronic charge, A the cross-sectional area, VD the drift velocity. We can rewrite this expression by replacing drift velocity by EE by m tau, where tau is the relaxation time. We get the expression for current as Ne square A tau V upon ml. And this V by I will be given by ml upon Ne square A tau. This V by I is called resistance. So we say that this resistance is depending upon length of the conductor and inversely directly on the length and inversely on the cross-sectional area. And this term m upon Ne square tau is known as resistivity or specific resistance, which depends upon the nature of material, because again mass and electronic charge is constant. So rho depends upon the number density and relaxation time. Number density depends upon the nature of material, and tau, the relaxation time, depends upon the temperature. So rho is called the resistivity. Another name is specific resistance. Now let's talk about the factors affecting resistance. As R is equal to rho L by A, so we say that resistance is directly proportional to length of the wire. More the length of the wire, more will be the resistance. Inversely on the cross-sectional area. Nature of material, because rho depends upon the nature of material, so this resistance also depends upon nature of material. And temperature, because rho is depending upon relaxation time. So there are 4 factors which affect the resistance of a conductor. They are length, cross-sectional area, nature of the material, and temperature. Now, what is resistivity? Resistivity or specific resistance of a material is the resistance offered by that conductor of unit length and unit cross-sectional area. What does it mean? That it is the resistance offered by a unit cube. Its SI unit is ohm meter. Resistivity depends upon the nature of material, but it not on the geometrical dimensions of the conductor. Second term is conductance or conductivity. Conductance is the ease with which electric charge flow through it. See, resistance is opposition to the flow of charge, and conductance is ease for the flow of charge. So, conductance is the reciprocal of resistance. Its SI unit is mho or ohm per ohm. Conductance is symbolized by G, and it is equal to 1 by R. Conductivity. Similarly, conductivity is reciprocal of resistivity, and its SI unit is mho per meter or per ohm per meter. Relation between drift velocity, resistivity, length, electric field, current density and potential. As we know that resistivity is given equal to E by J, or E is equal to NeVd, because J is I by A, that is NeVd. Vd is equal to E upon Ne rho. This relation tells that drift velocity is inversely proportional to resistivity, or drift velocity can be explained in terms of potential by replacing E as V by L. We get drift velocity's dependence on potential difference and length of the conductor. When temperature increases, drift velocity Vd decreases and resistivity, that is rho, increases. When length increases, drift velocity decreases. So these are the relation between all these physical quantities. Now, temperature dependence of resistance. As R is equal to mL upon Ne square tau A, where tau is the relaxation time, when temperature increases, the number of collision increases because of the gain in internal energy. The internal energy of the electron increases with the increase in temperature. So the number of collision increases, they collide, and the relaxation time decreases. Therefore, the resistance increases. Temperature coefficient of resistance, given by alpha equal to RT minus R0 upon R0 into T, where RT and R0 are the resistance at T degree Celsius and 0 degree Celsius, and ohmic and non-ohmic conductors. Let's talk about ohmic and non-ohmic conductor. Ohmic conductor are those conductor or those material which obey Ohm's law. The name is also indicating ohmic conductor which obey Ohm's law. And in this case, if you plot a graph between resistivity and temperature, the resistivity increases with temperature. For such material, rho at a given temperature is constant and it does not depend upon electric field. But if the temperature increases, its resistivity increases. Such type of conductors are called ohmic conductor. Non-ohmic conductor, which do not give the linear relationship between V and I, first thing, means which do not obey Ohm's law. And in this case, if we talk in terms of resistivity, the resistivity decreases with temperature. So, such type of conductors are called non-ohmic conductor. Third type of conductor are called superconductor. See, in conductors, as the temperature increases, resistivity increases. If we decrease the temperature, what will happen? Resistivity will decrease. So, for particular material, if the temperature is below critical temperature, then its resistivity becomes 0. Such type of material in which resistivity becomes 0 means no hindrance to the opposition of the hindrance to the flow of current. Such type of conductors are known as superconductor. Now let's talk about some questions. First question: at what temperature the resistance of bulb filament will become 200 ohm if its resistance at 100 degrees Celsius is 100 ohm and its temperature coefficient is 0.005 per degree Celsius. So here we will use the formula of the temperature dependence of the temperature coefficient of resistance, that is R dash minus alpha is equal to R dash minus R upon R T dash minus T. So T dash minus T will be calculated, and since T is known to us, T dash can be calculated. Second question. Dimensions of the block are 1 centimeter by 1 centimeter by 100 centimeter. If specific resistance of its material is 3 into 10 raised to power minus 7 ohm meter, then find the resistance between its opposite rectangular faces. So this can be done with the formula R is equal to rho L by A. Third question. Plot a graph showing variation of resistance of a conducting wire as a function of its radius, keeping the length of the wire and its temperature as constant. So, as we know, R is equal to rho L by A, and A is pi r square. If L and rho are remaining constant, then R is inversely proportional to R square. So we get an exponential graph for radius versus resistance versus radius. These are the solutions we can see. In first case we get 300 degrees Celsius, and in second case the length is 0.01 meter, that is 1 centimeter. Cross-sectional area is again 0.01 square centimeter, and resistance can be calculated as 3 into 10 raised to power minus 7 ohm. And third is the exponential graph. This is all about this topic. Thank you.